Section 3. Unsupervised Learning. Finding Hidden Patterns. Learning Objectives. By the end of this section, learners will be able to 1. Define unsupervised learning as learning from unlabeled data. 2. Understand how unsupervised ML discovers hidden structures or groupings. 3. Identify real-world global examples where unsupervised learning is applied. 4. Recognize strengths, limitations, and ethical challenges of unsupervised learning. Now we move to our second type of machine learning, unsupervised learning. Where supervised learning needed labels, answer keys, unsupervised learning works without them. Think of it as the computer being asked, "Here's a bunch of data. I'm not telling you what's what. Just see if you can find patterns or groups." What is unsupervised learning? Instead of learning from examples with answers, the algorithm explores data on its own and looks for clusters, groups that share similarities, patterns and structures, relationships hidden in messy data. This is like sending students into a library with stacks of books without labels. Over time, they start grouping books into categories: science, poetry, history, even though no one told them which is which. Everyday examples, music recommendations, Spotify, YouTube. Grouping songs by sound patterns or rhythms, even if no one labeled the mood. Customer segmentation, business. Grouping shoppers by purchase behaviors. Budget versus luxury buyers. Anomaly detection. Banking. Identifying unusual spending patterns that may suggest fraud. Language analysis. Grouping words by similarity across languages without direct translation labels. Strengths of unsupervised learning finds hidden insights that humans may miss. Saves time because it works without labeled data. Useful for summarizing big, complex datasets. Limitations of unsupervised learning. Hard to tell if the discovered groups are truly correct. Results can be ambiguous. Algorithms group based on math, not on human meaning. Risk of reinforcing stereotypes, e.g., clustering customers by profiles that oversimplify people. Global relevance. Unsupervised learning is widely applied. Healthcare, discovering hidden subgroups in patient data, e.g., types of diabetes. Agriculture, grouping satellite images of farmland to detect types of crops. Climate science, finding hidden weather patterns across decades of data for better forecasts. Retail in developing markets, identifying previously unseen customer groups, helping businesses adapt to local needs. Reflection. Imagine you're a data scientist working in a new education startup. You collect lots of data about how students interact with learning apps, but you have no labels for fast learner versus slow learner. How could unsupervised learning help you group the students? What risks might appear if the algorithm clusters them in ways that affect how they're treated? Key takeaways. 1. Unsupervised learning equals discovering patterns in unlabeled data. 2. Acts like an explorer or organizer, grouping without being told the categories. 3. Examples: music grouping, customer segmentation, fraud detection, climate analysis. 4. Strengths: helps in big messy datasets, finds hidden insights. 5. Limitations: meaning of groups can be unclear, may create oversimplified stereotypes.